Equations and inequalities here. So you've been learning in chapter 6 about equations and inequalities. So what we see that is when we have a simple equation, we have the left side equaling the right side. So that means that whatever is over here, whether it's one or more terms, it equals the same value, the same quantity as the other side. Here we know that simply x equals 2, and that is our solution to this very simple equation. Over here, this equation looks a little bit differently. We have 2 times some unknown number is equal to 4. Now you could probably do that in your head. 2 times what is 4? And yes, x equals 2. So the solution to this equation is also 2. Notice they're the same. All right, well, what about this one? Again, if you have a variable, it doesn't have to be x, it could be any variable, but it's some unknown value. And this, when it's written like this, that's divided by 2. So something divided by 2 has to equal 1. Well, is it 1 over 2? Does that equal 1? No. Is it 2 over 2? Does that oh wait, 2 over 2 equals 1. So here x equals 2 as well. So we have 2 as a solution to each one of these different equations. Okay? To solve an equation means that we want to end up with the variable in the equation, and you're only going to have one variable to solve for, I think, for the most part for this course. The one variable, you had to get it all by itself in order to find out what it equals. You see here, I have just x equals 2. So whatever is on the right side is what the variable equals. Okay? So that's just kind of trial and error in introduction to what equations are. Now, to solve an equation, sometimes the variable, and as you see here, the r down here, it's sort of embedded in a sort of a more complicated structure there. So there's the left side of the equation is a little bit more complicated, and we have to somehow shift everything around. We have to move things to the other side of the equation to get r all by itself, so we can see what r actually is. So how we do that is we do that by using inverse operations. With an equation, if we add something to one side of an equality, so let's say I have, this is an example from before, if I add the same thing to both sides of an equation, all right, x plus 3 equals 5. Notice that the equation is still true. If x equals 2, then 2 plus 3 does equal 5. I've added the same thing to both sides. And so we can add or subtract the same quantity from both sides of the equation and still have that equation to be true. That's a rule. Okay? Even multiplying and dividing, whatever you do to one side of the equation, you have to do to the other in order for it still to be true. Now, how do we get r by itself? Well, that's where the inverse operations come in. It basically means opposite. Let me just explain. Now, maybe your teacher explained this to you this way, maybe not. But let me just show you using the arrow diagram how this left side of this equation right here, how this was built. Okay? So in order, if we know how it was built, we know how to take it apart. Okay? That's the whole thing there. The whole thing there. So let's say we started with just r on this side. If r was just started for, the first thing that happened to it was divided by 4 to get r divided by 4 like this. You see it over there? Okay, and then what happened next to this side was we added 3 to get r over 4, or divided by 4, plus 3. You see, that's how this left side was built. And now to get r by itself, we do the opposite to get r back by itself. So just consider this. If I have r over 4 plus 3, if I did the opposite, if I subtracted 3, I would get r over 4. Now if I did the opposite of what we got to get here, if I divided this, multiplied this, by 4, I would get r back. So guess what? What we do to the one side, we should do to the other side in an equation. So I'm going to start with 7.2, and I'm going to use the opposite operations on 7.2, because that's how we're going to get r. That's where we're going to get how what r equals to. Okay? So you can see this is the equation as it stands right now. R over 4 plus 3 equals 7.2. If I subtract 3 from both sides, I get r over 4 equals 4.2. Now if I multiply by 4 both sides, I get this. R equals 16.8. So that's where the concept of inverse operations, or opposite. I like to call them opposite operations. So here's what it looks like with just using the algebraic solution, not the arrow diagrams. So again, see, we want to get rid of this 3. See, r is right there. I want to get rid of the 4 and the 3. I start outside. And inverse operations, a good idea to think about this. Remember the order of operations? Okay. When we do inverse or opposite operations, we flip those around and we do subtraction and addition first. Then we do multiplication or division next. Then we do exponents after that, and then anything inside the brackets. So it becomes SAMDEB. And so if you're wondering what to take apart first, do you want to do this opposite of dividing? You want to do multiplying first, or do you want to do subtracting first? Well, subtracting comes before multiplying. So that's how I remember that. Okay, so we subtract 3 from both sides. I get r over 4 equals 4.2. If you multiply by 4 both sides, I get r equals this times 4, 16.8. And that's how you solve an equation. Now to verify, I can pump my solution into my equation, and I'll check to see if the left side then equals the right side. So again, 16.8 was my answer. So look at 16.8 goes in for r. I do this on my calculator if you want, and then see if the left side equals the right side. That's what you can verify. All right. So let me do one with you, and I'll get you to try the other one. Or if you are ready to try these on your own, pause the video right now and try and solve for r for both of these equations. If you're not ready yet, I'll help you with the first one. Okay, so maybe you've tried these, and let's compare our answers. Or maybe you need a little bit of help. So let's do this thing. I want to solve for r. I need to get rid of this and this. Which one do I do first? I do the adding or subtracting first. So I'm going to do the opposite operation here. This is subtracted by 3 here. So I'm going to add 3 to both sides. This is going to go away with that, and I'm going to have 2r left on this side. That's it. And over here, I now have 10. Awesome. R is not all by itself yet. Okay, R is not equal to 10. No, 2 times R is equal to 10. So let's find out what R actually equals by dividing both sides by 2. And here you get R equals 5. Now, if we were to verify or check, okay, I would go like this. 2 times, what's my solution? 5. Minus 3 equals 7. Well, that's 10 minus 3 equals 7. 7 equals 7. It is verified. Okay? All right, what about the next one? Well, I'm not going to do the multiplying by 3 first. No, I'm going to do subtract 10 first. Okay? To both sides. So now I have r over 3. This is gone. Positive 10 minus 10, 0. So that's nothing left over there, right, in this part. Equals, what's 14 minus 10? 4. Okay? Now, I still need to get r by itself, so I need to multiply both sides by 3. And when that happens, you see the 3 divided by 3. You see 3 over 3 is 1. So that's how we get rid of the 3 there. Or you could think of it like this. It's 3r over 3 when you multiply it, right? Straight across. 3 over 1 times r over 3 is 3r over 3. These divide out, you're left with r. Equals 12. So r equals 12. And if I want to verify or check, I simply go 12 instead of r. And I see if the left side of this equation equals the right side of this equation. And here you see that it does. That checks out, so those are our 2 answers. Okay, so that's solving equations. Again, you want to find the missing variable. Whatever you do to one side of the equation, you have to do to the other side to make sure that it stays equal, right? That they stay equal. All right, so that moves us to inequalities. Another thing you focused on in this chapter was inequalities. Inequalities, please don't let them freak you out, okay? They're just like equalities, you see? Just like equalities, except they're not equal sometimes. Sometimes they could be not equal. So, you know, in equations, we have one answer. In inequalities, we could have lots of answers, okay? So think about this. If x was less than 2, and you know how I remember which is less than and which is greater than. This is the way my teacher taught to me when I was in elementary school, and I still think about this sometimes. But if you make this particular sign, some kind of crocodile or alligator or something, and it's got the big teeth, right? Okay, it's going to eat the larger side. So it's faced this way. It wants to eat a whole bunch of food, not a small amount of food. So this side is less than this side. This is the bigger side, okay, wherever it's eating. The other nice thing about this is, of course, get rid of the teeth and the crocodile and everything else. This, of course, does spell, less. Here, I'm talking about all values that are less than 2. So that would be like 1 or 0 or -1 or -1.2 or so on, right? So if we do this, or equal to, that means I can include 2 in this list. That's all it means. Possible solutions for x could now equal 2 as well. All right, so here I have less than. Here I have greater than. This is greater than or equal to. This is less than or equal to. So they're basically saying find the missing values that make this inequality true. Okay, an inequality. So let's go back to our original x equals 2. Okay, that's an equation, one solution. If I do this, okay, fancy, see what I did there? Pretty cool, huh? That means x, the unknown value, or values, that means there's lots of values, because I'm talking about x value that could be greater than 2 or equal to 2. So there's an infinite number of answers there. So it's a solution set is what it is. Now look at this. Remember this one? 2x is equal to 4, remember that one? What if I did this? 2x is less than or equal to 4. Well, we know that x would equal 2, right? X equals 2. But because now this 2x can be less than 4 as well, x could also be anything less than 2 as well. So it could be 1, or it could be 0, or it could be anything negative. So 2 times 0 is 0, right? And that's less than 4. 2 times -5 is -10. That's less than 4. So you see how the signs kind of follow the same way as an equation. And that is true for a lot of equations or inequalities. What about graphing? What about graphing the inequalities? Okay, so if you're asked to graph inequalities like this, f is greater than or equal to 3.5, you start with a number line, and you place 3.5 on the number line. Now notice that this number line has a solid dot at 3.5. The solid dot is for the equals part. Okay, that means it includes 3.5. And if f, or the missing values, or the solution set for the unknown, is greater than or equal to 3.5, you have to put an arrow to the right. Remember, anything to the right on a number line is greater than. Anything to the left is less than. Always the same. Okay. This one, g is less than -7/4. So you would find out where -7/4 goes on the number line, and of course that's 1 3/4 negative, right? 4 goes into 7 one time with 3 left over, so it's -1 3/4. So you put that there. But notice this is an open circle because there's no or equal to. So -7.4 is not included in all the possible values here. And so you just make an arrow going left. Why? Because it's less than. G, these are all the g values over here. Look at all these g values over here. And they are less than -7/4. They're less than this value right here. So all the g's are on this side. Okay? Got it? All right, hopefully that's helping. Now we're almost done. I am going to talk about this. Okay, so when we solve an inequality, okay, the inequality sign, there is one little trick, one little difference when solving an inequality versus an equation. I just want to show you this for now. Okay, an example. 2 is less than 5, right? Okay, 2 is less than 5. If I add something, the same thing, to both sides, I get 5 less than 8. Is that still true? Yeah. What about if I subtract something? Well, this is 1 is less than 4. Is that true? It is. Now watch this. What happens if I took that same inequality and I multiplied by a -2? And of course, I'll do that to this side as well. What happens? I get -4 less than negative 10. Now we have to look at this very, very carefully, because on a number line, remember, whatever's less is to the left. So negative 10 is actually further left than negative 4. Do you see how this does not make sense? That's not true anymore. So something happens when we multiply or divide, as it turns out. When we multiply or divide by a negative, what happens is we have to flip this sign. We have to flip it. And then it's true. All right? And over here, again, if we divide, let's divide by some negative number. So divide by negative 5, divide by negative 5. This is negative 2 over 5 is less than negative 1. Nope, negative 1 is less than. So you have to flip that sign. Okay, so we flip the sign. Here's some examples. All right, if I multiply or divide, let's say, I want to get x by itself here. Remember, when solving an inequality, it's really the same as an equation, except for when we divide or multiply by a negative. So what happens here? This becomes x when I divide both sides by negative 1. If I flip the sign, then this is absolutely true. Okay, well, let's think about this. Let's say that x was negative 2. Okay, if x was negative 2, that means this is what it would be. And that's, 2 less than 5. That is correct. Right? So as long as these values in here are greater than negative 5, it still becomes true. You could plug any value in that's greater than negative 5, like 0 or 10 or 300, and it'll make this original equation true. Over here, let's just separate this example. So over here we do all the opposite operation steps exactly the same as an equation. So I'm going to subtract 2 from both sides because there's a positive 2 over here. Those are going to be gone. Negative 3x is greater than or equal to what? What's 8 minus 2? That's 6. Don't flip the sign when you add or subtract. Do not flip the sign when you add or subtract. But at this point, when I have to divide by a negative 3 here, in order to get x positive and all by itself, then I flip the signs. And of course the equal sign doesn't flip, right? It just you can flip an equal sign, but it's the same. So you flip, and this becomes what? X is less than or equal to negative 2. And if you were to check that, okay, let's check that. So what's the number that's less than negative 2? Oh, let's say negative 5. So let's say I put 2 minus 3 times negative 5 in there. Is that greater than or equal to 8? Well, that's 2. That's minus a negative 15, which is the same as plus 15, greater than 8. That's 17 greater than or equal to 8. That is 100% true. So you see it works out. Okay? So the flipping the sign when you multiply or divide by negative is the one thing that you have to be careful of. That's one thing that's different. Okay? Why don't I give you a couple things to try out here, just some practice questions, and you can do those, and I'll show you the answers in a bit here. Okay? So here's some practice questions. I'll show you the answers in just a minute. So pause the video now and give this a try. See if you can solve for W here in each of these 4. The first one should be W equals 12. The second one, W equals negative 7. The third one, W is less than or equal to 52 over 3. And the fourth one, W is greater than 10. All right, and here's the worked out solutions for those. I do have 3 more that I'll ask you to do just to double check to make sure that you know what you're doing for this one. This is from the review in the textbook. So if you want to give these 3 a crack, these are a little tougher, I would say. And yeah, so go ahead and give those a try, and I'll show you the solutions in a minute. So pause the video now and give those ones a try. Through this. So here we're going to divide by negative 1 both sides. And we're going to, each of those are going to be positive, and remember, we need to flip the sign. And here's the graph. Your teacher might ask you to put more numbers on the graph there. I'm not really sure, but you know, you might need to do that. So for the second one, all right, we need to expand this. We need to multiply that through. So that's 3t plus 6. Keep that sign and write everything else out the same. Now we're going to gather like terms. So terms that are the same on both sides, we need to get them onto the same side. So I added 5t to both sides to get 8t over here. Then I subtracted 6 from both sides to get this step. And t here, once we divide by 8, is greater than or equal to 5 over 8. Over here, again, a little bit tricky. We've got fractions all over the place. Look at the denominators, 4 and 2, multiplied by the least common multiple. So 2, 4, 6, 8, right? 2 and 4, the multiples there, right? We're going to multiply by 4. 4 is the lowest common multiple between those two. If we multiply everything, both sides, by 4, we get rid of all the fractions. So you end up with 4 times m over 4 is just m. 4 times 5 is 20, and so on. Again, gather like terms, add 4m to both sides. You get 5m plus 20 is less than or equal to 2. Subtract 20 from both sides, and then divide by 5, and you should get this for an answer. Okay, so yeah, do some more practice from your textbook. I hope that has helped. Just some review for Chapter 6. Equations and inequalities, remember, are very, very similar. And the only trick with the inequalities is if you multiply or divide by a negative, make sure you flip that sign. All right, there you go. I hope your test goes well. And there's many more videos that you can find for all sorts of different math classes that you can find on Mr. MathWell. So look up YouTube, just look up Mr. MathWell, science and math videos for you.